Well, hello there. Sion Batson here from Sion Batson Tutoring, and in this video we will be adding, subtracting, and combining like terms. Very important concept for all of my 6th graders, my 7th graders, and even if you are getting ready to take the GED exam, this video is for you. So join me. Now, this exercise is out of my 7th grade math workbook. You can master 7th grade math next generation learning standards. This workbook covers all of the next generation learning standards as well as all of the Common Core learning standards for 7th grade. This workbook is filled with very simple and easy to follow notes, step-by-step examples, guided examples, and more than 1100 practice problems and answers. Parents love this workbook, teachers love this workbook, students love this workbook because it is the ultimate study guide to help your scholars get ready for the 7th grade state exam. So if you have a 7th grader, I would highly recommend that you grab them a copy. You can get your copy from Amazon. Now, to our video. When adding, subtracting, and combining like terms, the general rule is we can only add or subtract terms that are alike. So we must keep that in mind. That's the most important rule, yeah? We can only add or subtract terms that are alike. Now, if you need to review like terms, I recommend that you go check out my video, terms, like terms, and identifying like terms, then come back, okay? That video breaks down what a term is, what like terms are, and in that video we also identify like terms, okay? So I would recommend you go check that video out first, then come back. Now, before we begin to add and subtract like terms, I want to talk about something very important. The lonely variable. Whenever a variable is by itself, there are two things missing, or two things hiding. One is the coefficient. The coefficient will always be 1. And again, the coefficient is the numerical value in front of the variable, or the numerical value that is multiplying the variable. The coefficient is just the number in front of the variable, okay? So whenever a variable is by itself, the coefficient will always be 1. So don't forget that. Even though you don't see it, you have to remember that there's a 1 there. Also, when a variable is by itself, the exponent is also 1. So there are two things hiding whenever the variable is just sitting there. The coefficient, which is 1, and the exponent, which is 1 as well. So anytime you see a variable, don't forget. If you see, for example, let's say there's a y just sitting there, you have to remember that there's a 1 in front of the y, and there is a 1 as the exponent as well. So far, so good? Perfect. Now, I am going to teach you two very simple steps that will help you master the concept of adding, subtracting, and combining like terms. Step 1, we will group the like terms if they are not next to each other. Step 2, once we have them grouped, we will add or subtract only the coefficients. Note, I put a note for you. When adding or subtracting, we do not touch the variables nor the exponents. We only add or subtract the coefficients. Don't forget that, yeah? We will only add or subtract the coefficients. Never touch the variable, never touch the exponent. So far, so good? All right. Let's try one. Let's say we have 2x plus 4x. Now, first question, are these two terms alike? Well, yes. Why are they alike? They are alike because they have the same variable. Yes, the variables here is x, the variable here is x. So the two terms are alike. Now, because they are alike, we can add. And again, remember, when we are adding, we're only adding the coefficients or the numbers in front of the variables. So the numbers in front of the variables are 2 and 4. If we add 2 and 4, we would get 6. And the x stays. So the answer is 6x. It's that simple. Only add or subtract the coefficients. Leave the variables alone. Get the idea? Alright, very good. What if we have x plus 7x? Remember, the lonely variable, whenever the variable is by itself, there's always a 1 in front of it, or the coefficient is always 1. So here, again, our terms are alike because they have the same variable. Same variable, x. Yes? So because the variables are the same, we can add. And when we're adding, we're only adding the coefficients. 1 and 7, or 1 plus 7 gives us 8. So the answer is 8x. That's simple. Very simple, my friends. Oh, my friends. Very simple. Let's say we have, let's say 7y squared plus 8y squared. Can we add these two? Yes. Why? Because the two terms are alike. Remember, terms are alike if the variables are the same and the exponents are the same as well. Okay? The variable and the exponent here is y and 2, and here the variable is y, the exponent is 2. So both terms have the same variable and the same exponent. Yes? So they are alike, so we can add. And again, when we're adding, we're only adding the coefficients. 7 plus 8 gives us 15, and the variable and the power stays the same. So far, so good? All right. Excuse me. Let's make it a little more interesting now. Well, before we go on, I'll give you one to try on your own. Try 6x. Take x. Give the one a try. Pause the video, try it, then come back and see if we get the same answer. Okay? Perfect. Now, welcome back. So first, because we have a lonely variable here, I'm going to put a 1 in front of this x because I know that whenever a variable is by itself, the coefficient is always 1. Don't forget that. So whenever you're working with these variables and you see a lonely variable, I always recommend for you to put that 1 there so you wouldn't forget it's there. Okay? Now, let's go. These two terms are alike. So because they are alike, I can subtract 1 and 5. Sorry, 6 and 1. Yeah? I can subtract 6 and 1. If I subtract 6 and 1, I would get 5. And the variable stays. We never touch the variable when we're adding or subtracting. Yes? Alright. Let's make it more interesting now. These are too easy, right? I know. You guys are sitting at home saying, I wish Sion would make this stuff more challenging here. So let's do 2x plus 4y plus 7x. Let's do this one here. 2x plus 4x plus 7x. Very interesting here, right? Do you see any like terms? Yes. What are they? Say it, let me hear it. Very good, 2x. And what's the other one? Very good, 7x. Why are they alike, may I ask? Very good, because they have the same variable. Very good. And the variable is x. Now, note this right here. You note when I'm circling my like terms, I always circle the sign that's in front of these terms. Why? Because in algebra, the signs that come in front of a term, right, is attached to that term. So wherever that term goes, guess what? That sign follows. Okay? Don't forget that. Now, our two like terms are 2x and the 7x, yeah? So I can put them next to each other, or I can group them, or I can combine them. Yes? So I put my 2x, and look what happens. The positive 7x comes. Now note how the sign follows that 7x. This sign isn't just sitting there floating by itself, okay? Now we can add, yeah? What is 2x plus 7x? Very good, 9x. We aren't done, we still have a 4y here, right here. So after I combine the x's, I'm left with 9x. Let's use a different color ink. I'm left with 9x plus 4y. Now, would I be able to add 9x and 4y? No. Very good, my friend. Why not? Because the variables are different. And because the variables are different, the terms are not alike. And remember, what's the general rule? We can only add and subtract terms that are alike. So the answer here would be 9x plus 4y. We're done. All right, very good. You guys are all smart. I know. I'm just glad that you guys are willing to sit and listen to me. Okay, now, time for a challenge here. All right. I want you guys to try this one here for me. Give it a try, okay? Pause the video, give it a try, and then come back and see if we get the same answer. Okay? Now, welcome back. Let's see if we get the same answer. First things first. Do you see any like terms? Yes. We have 12x to the second power, and we have a 7x here to the second power. Yes? So we can first deal with this group. So let's do the 12x second squared. Take 7x squared. Now, quick question. Why are these two alike? They're alike because they have the same variable and the same exponent. We remember that from our like terms video, right? So if we subtract these two, we'll get 5x to the second power. Now, do you see any more like terms? Yes. We have 4x here and 6x here. So we can put them next to each other. 4x plus 6x will give us 10x. Yes? So we are left with 5x to the second power plus 10x. Now, why aren't these two alike? If you remember, they're not alike because even though they have the same variable, the exponents are different. The exponent here is 2, and if you remember, the exponent there would be 1. So the exponents are different. So terms are only alike if the variables are the same and the exponents are the same as well. All right, so the answer will be 5x squared plus 10x. How was that? All right, can we do one more? Do we have time for one more? Yes? Perfect. Let's do one more. Let's say we have 1/2 x plus 4y plus, let's say, how about that? Yes? So this is what I want you guys to do for me again. Pause the video, give it a try, then come back and see if we get the same answers. Okay? All right. Now, welcome back. Let's work and see if we get the same answer. Okay? First, do you see any like terms? Yes. 1/2 x and 5/2x. They are alike. Why? Because they have the same variable. So we can add them. So we add 1/2 x plus 5/2x. I remember when you're adding fractions, the key is the denominators must be the same. Yeah? Right. And when we're adding, we don't ever touch the denominator. Yeah? Remember from fractions, so we'll get what? 5 plus 1 of 1 plus 5 is 6. So we get 6 over 2x or 3x. Because 6 divided by 3 is 2. Yeah? Now, we aren't done. Let's come right here. Well, yeah, let's put it right here. We have 3x. But what's left? We cannot forget this 4y. Yeah? So we put our 4y back. Let me write my 4 properly. So the answer there is 3x plus 4y. Now, can we add these two? No. Why not? Because they are not alike. Yes? How was that? Very good. Yes? I really hope you guys get the idea of adding and subtracting like terms. Now note, in this video, all our answers are positive. I'll do a second video, and in that video, I will include negative answers, okay? So this is part 1 of the series. In part 2 of the series, I will include negative answers or more negative integers, yeah? Or more negative terms, okay? So this is just the, let's say, intro, okay? So again, I really hope you guys enjoy this video here. This exercise again is out of my 7th grade math workbook. You Can Master 7th grade math, Next Generation Learning Standards. You can get that workbook. This exercise is out of that workbook, and all of the practice is in that workbook as well. You can get a copy from Amazon. Until next time, enjoy your math homework, and remember to practice. See you.